Hi, in this video we're going to look at absolute value equations that involve two absolute value terms. So for example, if you have absolute value of ax plus b equal to absolute value of cx plus d. In this scenario, we know that each of the expressions inside the absolute value could be positive or could be negative, right? So let's just think about the scenarios before we even read the rest of this slide. So we know that ax plus b could be equal to cx plus d, right? If they're both positive, or maybe they're both negative for all we know, right? Could have negative quantity ax plus b equal to negative quantity cx plus d, okay? Or maybe the first one is positive and the second one is negative. Okay, so ax plus b equal to negative quantity cx plus d. Maybe the first one is negative and the second one is positive. Negative quantity ax plus b equal to cx plus d. Okay, so given that these are the four scenarios that are possible, let's break it down a little bit because you don't have to solve each one of these, right? So if we look at these first two, okay, when we leave them both positive or we make them both negative, if we make them both negative, you can multiply both sides by -1 and get the first equation, right? That they're both positive. Okay, so one option is just to leave them both positive. That takes care of the first two scenarios there. And then the second two scenarios, we're leaving one positive and one negative, right? If we took one of these and multiplied it by -1, we'd get the other, right? So thinking about it that way, there's really two scenarios. There's only two things that we need to be worried about. One, we can make them both positive, right? Or two, we can make one positive and one negative. And it really doesn't matter which one you make negative, but usually I make the second one negative, but it doesn't matter. Okay, so with that in mind, let's solve a few of these. Okay, so let's solve the absolute value equation where we have absolute value of 5x plus 7 is equal to the absolute value of 4x plus 3. Okay, so there's two scenarios. Remember, you can leave them both positive, 5x plus 7 equal to 4x plus 3, or 5x plus 7 is equal to negative quantity 4x plus 3. Make sure you make the whole thing negative, okay? And you've got to solve them both, right? Those are part of the solution set there. In this first example, I'm going to subtract 5 from both sides. So I have 5x plus 7 minus 7 equal to 4x plus 3 minus 7. So I have 5x equal to 4x minus 4. So now I'm going to subtract 4x from both sides. So I have 5x minus 4x equal to 4x minus 4x minus 4. So now I have x equal to -4. All right, with this other equation of 5x plus 7 equal to negative quantity 4x plus 3, the first thing you want to do is distribute the negative. So I have -4x minus 3. So now I need to subtract 7 from both sides, so I'm going to have 5x plus 7 minus 7 equal to -4x minus 3 minus 7. So I have 5x equal to -4x minus 10. Now I need to add 4x to both sides. So I have 5x plus 4x equal to -4x plus 4x minus 10. So that leaves 9x equal to -10. Divide both sides by 9. X is equal to -10 ninths. Okay, so the solution set is -4, -10 ninths. So I want to do a couple of more examples of that same type because just to get it ingrained. So this is another absolute value equation to solve. Absolute value of x minus 9 is equal to absolute value of x plus 6. Okay, so again, I'm either going to leave them both positive, and by the way, when we do this, make sure you take the absolute value signs away, right? So we're saying x minus 9 equal to x plus 6, or x minus 9 equal to negative quantity x plus 6. All right, so for the first equation, I'm going to start by subtracting x from both sides. So I have x minus 9 equal to x minus x plus 6. So that leaves me with negative 9 equal to 6. Is that true? No, it's not. Okay, so that particular equation doesn't yield a solution. Now that doesn't mean that the other one won't. Let's take a look. So with x minus 9 equal to negative quantity x plus 6, I'm going to distribute the negative through. So I have x minus 9 equal to negative x minus 6. So now I'm going to add x to both sides. X plus x minus 9 equal to negative x plus x minus 6, right? So that leaves 2x minus 9 equal to negative 6. Now I'm going to add 9 to both sides. So I have 2x minus 9 plus 9 equal to negative 6 plus 9. And I have 2x equal to 3. Divide both sides by 2. X is equal to 3 halves. Okay, so the only solution to this is 3 halves. Okay, so here's another one. Absolute value of n minus 3 equal to absolute value of 3 minus n. And of course our task is to solve this. So I'm going to have n minus 3 equal to 3 minus n, leave them both positive, right? Or n minus 3 equal to negative quantity 3 minus n. Okay, and again, with that second one, whether you make the second equation negative or the first equation negative, it makes no difference. I usually let the second equation be negative. All right, so in the first equation here, I'm going to add n to both sides. N plus n minus 3 equal to 3 minus n plus n. So that leaves 2n minus 3 equal to 3. I'm going to add 3 to both sides. So I have 2n minus 3 plus 3 equal to 3 plus 3. 2n is equal to 6. I'm going to divide both sides by 2. N is equal to 3. Okay, so let's see what the second equation produces. The first thing I need to do is distribute the negative through. So we'll have n minus 3 equal to negative 3 plus n. So now I'm going to subtract n from both sides. So I have n minus 3 equal to negative 3 plus n minus n. So I have negative 3 on the left-hand side and also negative 3 on the right-hand side, right? N cancels out entirely. Is that a true statement? Yes, it is. That means it's true for any n we pick, okay? So that means that the solution set is all real numbers, and I'm just going to state it as negative infinity to infinity. Okay. So I just want to take a look at what's going on here, okay? Because if we're getting all real numbers as a solution, that means that the graph of y equal absolute value of n minus 3 and y equal absolute value of 3 minus n is the same. They're overlapping, right? Okay, so we noticed that when we let the second equation be negative, all of a sudden we ended up with the same equation. So let's take a look. What's happening here? Because on the face of it, it doesn't look like they're the same. But if we have the absolute value of n minus 3 equal to, I'm going to just factor a negative out of that second expression. Okay, so inside the absolute value signs, I have negative times negative 3 plus n. Okay, negative 3 plus n, that's the same thing as n minus 3, is it not? Yeah. Okay, so when we take the absolute value of negative n minus 3, what is that going to give us? N minus 3, right? So it makes sense that n minus 3 equal to n minus 3. Yes, that's true for any n. It doesn't matter, right? So if we were to graph each side of this equation, the graphs would be exactly the same. They would be identical. So I just wanted to point that out.